payload where I say or 1 equal to 1 or double single quote equal to single quote. This is going to break the XPath execution logic. So what is going to happen is this particular XPath signature is going to always match at the first user of the XML document. So I automatically become the first user. Whoever is the first user, I don't know his name, username, his password, but I actually become that. So in this particular case, the username is the Shreeraj is the first user, so I get the token of that particular user. Now, this is becoming very relevant because what is happening nowadays is that when you go and do authentication, it's not actually doing the authentication against database. What it's going to do is when you boot up your application will make the database call and store all the credentials into your XML document in memory and start running these XPath queries in the memory so that your response will be much more faster. So if these kind of a mechanism is implemented, then you can actually go ahead and identify XPath vulnerabilities in your SOAP envelopes. Another is LDAP injection, which is a very complex one. They will do LDAP authentication at the back end, and the whole LDAP, once you compromise LDAP, what is going to happen is you get the access to various different levels. You can end up being a user of that particular company, or you can actually go ahead and become a user of the whole company, which is whole application companies which are using that particular software as service. So one of the large communication company which we scanned 2 weeks back, where actually we were able to do successful LDAP injection and become an admin on the box. And once we are admin on the LDAP, actually we get the access to the entire rack of their application, their physical server. So you can start making the calls through the LDAP and start changing the parameters, start changing the rights which you have, and start taking the rights which you don't have, something like that. So that's the LDAP it's a very typically it is a complex, but if you want to do a very quick test on LDAP, use star, because star is a LDAP query filter for getting all the rights. So we inject it with the star. Else, like you have to look at the message, and to successful execution you have to use a combination of a star, single quote, and a bracket, not the curly bracket, just the square circle bracket. Or you can go ahead and get access to the file system access. Now this file system access is essentially very important when you are looking at the storage APIs as well. So in this, actually what we are doing over here, for example, doing the file access call. So in the file access call, you actually go ahead and pass on the file name over here, and you get the security error because you may not have rights on it or something like that, or that file is not there. Then you do a // and try to access some other's file. Now, this particular attack was successful on Amazon storage. Someone has actually go ahead and fetch all the images which are loaded on that his server, which was actually the whole attack has been demonstrated in the black hat by Salesforce. So this is where you can actually pass on the parameter. In this particular case, we just pass on a // but in that particular case, what you can do is you pass on the slash and the GUID of the other's client, and then start fetching the file system from the server. So this is how various different possible attack vectors which you can utilize. Another way is you can do a SOAP brute forcing. We have a typical brute forcing on the application. You can do a SOAP brute forcing, maybe the username and a password of candidates over there. Let me show you quickly that. Okay, here is the web services auto audit. So here is our auto audit, and one of the parameters which you can see over here is a brute forcing. Enter information, select which parameter, combination of a parameter which you want to brute force, and pass on the username, password file, and start brute forcing with the popular names or popular lower hanging users which you know. So this is a typical way you can actually go ahead and brute force SOAP envelopes as well. Then you have a parameter overflow. This is essentially the parameter overflow is particularly very specific with the libraries to libraries. Some of the libraries of the XML processing are vulnerable to it, some of them are not. So you can start using this particular attack. operating system access where you are running in your VM, or you are running the platform-driven APIs, or you are running with the infrastructure level API. These are some of the command injections you can try on the cloud API with a pipe or a semicolon, where you pipe your output to someone else's output, or you pipe the essentially output to the next input. So you say, for example, whatever next command you want to run, pass on to the file system, and then it may run, may not run, depending on the fuzzing capability or the vulnerability on the server. This may work or may not work. So say, for example, injecting command to source here. So you have this WSDL, where get user info, which you are getting from the system. You make that call, invoke that, and over here you can see user, for example. So I'm John, and I'm seeing my profile over here. So John has his own profile over here. This is a complete profile coming from, say, for example, LDAP over here. And now I just pipe the command to say some kind of a command, say dir C colon, and then go send, and you can see the whole directory structure which is coming back. So this is something which is very interesting to test in the cloud API, where it is hitting against your platform or against your infrastructure. It may not work in the SaaS framework, because it's a software as service, never had a deep-rooted access to the platform or infrastructure, but the services which are exposed specific for a platform or infrastructure may have these kind of vulnerabilities as well. So this is how essentially you can start. The last attack, which is also very popular, is the session hijacking with the web services, because each of the web services method, if they are enabled with a session equal to true, then actually the whole session management mechanism you can test. What kind of a tokens it is taking, try to reverse engineer a token and try to identify the access mechanism. So cookie tampering is possible, and nowadays, like if you look at analyze all different framework very closely, there are two different sessions now there. One is your application level session management object, and then there is a framework level session management object. So say, for example, if you're running with the DWR, then DWR inside your higher level session, they are managing their lower level session. So DWR has its own session management object running on the server side. So it is not just relying on the web server. Say, for example, you are running DWR inside a WebLogic, then you have a WebLogic cookie, and then every AJAX call DWR making from a browser will have its own little HTTP session cookie. So this is how interesting session hijacking is possible with the SOAP API or any other API which we have. So you have a scanning strategies, manual invocation, and this response analysis, dynamic proxy creation and scanning. Now this is a very important aspect when you are dealing with a different kind of a web services. Say, for example, your web service is running against Python, then you need a Python proxy. Or your web service is running again on the Ruby platform, you need a Ruby proxy. Or similar with the JWS. So all these different framework has their counterpart. So you can utilize those libraries. Say, so for example, PyAMF or AMF proxy. If you want to do AMF driven proxying, you can use the Python AMF or such. So this is an interesting aspect of doing that. Fuzzing web services stream with XML or JSON. Response analysis is the key. So these are some of the things we are looking at. This is, for example, if we go and do a web services fuzzer. So we have a WS fuzzer and a WS scanner which we can use. So what I'm doing is I'm just passing the fuzz load over here, which say these are the patterns which I want to fuzz. Say, for example, this is a pattern load which I'm looking at. I'm interested in 500 and fault code. I'm interested in this and pattern sample. So I'm selecting these two over here in my execution. And then pass hash, fuzz hash, wherever you want to do, whichever node you want to fuzz. You can do a multiple node fuzzing, or you can do a single node fuzzing. So this can be a SOAP envelope, this can be JSON, this can be customized envelope, whatever it is, you can pass on and then start fuzzing the whole envelope. So you can see, start looking at all the red errors where whatever regular expression you have passed on in the regular expression pattern matching you can identify. So let the application run overnight, and then you can see all different red flags, which may be interesting, may not be interesting. Depends on what you have found from the application. So this is how essentially APIs, which are part of the cloud, would get analyzed. So we do injection faults, and then we analyze the fault and look for fault code info. And then we come up with the defense from providing a web services or a SOAP-driven defense or XML-driven defense, which is a different approach from the traditional filtering. So say for example over here, we have a tool called web to wall, which is a typical tool for securing your XML envelopes. So you can get this WSDL. This is a source code for that, which is also on the web if you want to try or learn. So this is essentially what it is doing is it's going to grab all different parameters in your pipe. This is a .NET code sitting in your IIS pipe. So you can skip this. What I'm interested is, so this is a post method, grab post method, get all different bunch of information converted into a string, and then run certain regular expression matching, and if you find that particular match, then come up with a security error, so someone cannot inject various different parameters in your XML envelope. So now say for example over here is my, okay, so now we started this, and so for example get code is a method which I want to protect. So now on the get code, for example, if I say IBM over here, so I get IBM's value over here. Right. Now this has been already, web to wall is already loaded on this services. So now with certain rules. So now say for example, if you enter more than 3 characters over here, or if you enter certain blacklist parameters on over here, you will get blocked, automatically get blocked. So say for example, if I try single code over here, I will get the security error. This is a part of the typical node. So I am like a node-driven filtering. I am looking at the symbol node over here, and I will get that security error. So this is where next generation web application firewalls are going to come and address. This can be XML, this can be JSON, etc. And on top, you need all secure coding principles for your cloud-driven APIs or APIs which you have implemented on that. Okay, so this is what about SOA. Any question on this? So we started on running the tools against the cloud, try to fetch. Essentially, you do a primary or a secondary discovery, try to identify where the cloud API is sitting, where the WSDL is sitting, fetch that, profile them, and then start fuzzing them and invoking them, and try to play around with it and try to identify what kind of vulnerability you can discover. So this is the server-side possibilities in the cloud which we are looking at. Any question? Yeah.
Is there any commercial Web 2.0 firewall?
There are no commercial Web 2 firewall, but there are IBM and Intel. Both of them has an XML firewall. So you can protect your SOAP envelopes on it. But if your envelopes are JSON or some kind of a customized framework, then they will not work. So there were a company called Reactivity which was taken over by IBM, and they have like 3 or 4 players out there. They provide XML-driven firewall. Lastly, I heard that F5 is implementing something on top of their web firewall. Imperva has a WAF, but I don't know whether they have implemented XML rules on the stack or not. But work is going on. Like maybe in 1 year or 2 years, we start seeing these kind of a defense. So we just have to say, like applying a rule, we say like, okay, this is my envelope. This at this particular ASMX there will be envelope, and there will be this particular node. If it has this, just block, or a whitelist, maybe like allow this value only. Okay, so this is all about client side, and finally, let's go client side. Now, on the client side, some of the attack vectors are traditional and the same. So say for example, we quickly go to the